Okay, hello folks. At this point, I've done two video segments on buckling of a very simple part, which was actually a rectangular composite piece. What I would like to do now is look at a slightly more complicated geometry that is shown here. It's a cylindrical panel with a circular hole. So the size of the panel, let me move this thing to the slideshow, by the way. It's easier to discuss it that way. Okay, so the geometry is shown here, and the sides of this cylindrical panel are all simply supported. Okay, we'll talk about that thing in a few minutes. And we are applying a compressive load, and we would like to know what is the load that causes this panel to buckle, or the critical load, the first load that causes the panel to buckle. The geometry is given here as far as the dimension goes, and I'm going to be creating that later. Now, this is not unusual because if you look at an aircraft fuselage, there are many portions of it which actually resemble that. So here is, for example, a cutout of a the skin with the window here. It's not a circular hole, but it resembles that. Okay. And as far as the model is concerned, I talked about the edges being simply supported, and all that means, for example, the rotations are free, they're free rotations, but as far as displacement goes, they're specified in this diagram. So we're going to be we're going to be following this particular boundary condition. Now, notice, for example, on this edge, obviously, because of the load, it can compress and eventually it will buckle. That's why UZ is not given. UZ is actually is not zero. Okay. Now, again, here is a real aircraft, and the fuselage. You can see there's a lot of locally buckled portions, and there we are. So this is not uncommon. Now, the actual composite that I'm going to assume is given by this layout stack up sequence, and there's 16 layers. Notice that inside of that there's 8 of them. Okay, and then this S means that it's symmetric, so it's repeated, and the thickness of each layer is 0.0056 inches. Now, the material properties that we're going to be using or given these are the Young's modulus in the fiber and transverse directions. It is shear moduli and the Poisson ratio. And uh, this video is going to be done in two segments. First is to create the geometry and uh, the the composite model, and that's going to be part one of the video. The second part is actually going to be doing the buckling analysis. Okay, so I didn't want to put everything together because it could take an hour, and that's too long for a video. So here's the situation. Uh, when it comes to creating these 16 plies, you can do that using the manual ply creation, but notice that we have to do this something 16 times. Most of the videos that I've done on composites, except for one or two of them, were done manually, okay? But here I'm going to be using some of the features that are available in CATIA. For example, I can create a zone, and based on the zone, I can create ply. See, you create a zone group, and then a zone, which is that panel, and then you go to the ply toolbar, and you create the plies based on zone, but that is done in a random way. I mean, CATIA does it. There's no stacking sequence. It just creates all the plies, but the order is not right. So what we do is we take the information and export it as an Excel file, so that we go there, and the eight plies that we create, we can reorder it in any way we want and save it, and then we're going to import it back into CATIA. So export Excel, import Excel, and so we're going to have the 8 plies ordered in the way we want, and then we use the symmetry in order to create the mirror of that. So this is a strategy we're going to be following. So in fact, this first video segment is creating geometries, very simple, and then following the scheme, okay, and creating the composite panel, okay, and then video 2 is going to be a buckling analysis of it. By the way, in this piece, you specify the material. When you create a parameter, you can in it specify the material, direction, and create a laminate made of these, these plies and the rosette. And then when it comes to creating the group, okay, you specify the surface and the draping direction. And when it comes to specify the zone, you need to specify the contour and which laminate you're going to be taking. And of course here already discussed it, but we will come across, when it comes to importing and exporting, we will come across these dialog boxes that we're going to discuss as time at the time that's needed. Okay, so now this problem is coming from Dr. Stanley's PhD thesis, which is right now 35 years old, but it's a classical reference. So there's going to be two parts to this second part. One is a static case. In other words, we're not going to assume buckling. We just apply a displacement to this the side, one of the sides, and then the reaction force. Calculate the reaction force. This is the result from Stanley, the thesis of Stanley, and we're going to compare it against that. And then we're going to do a buckling analysis. And his calculation shows that these are the first three buckling modes, okay? Yeah, so we'll come to this in the second video segment. The other comment that I want to make is that my calculation is done in Catia V5-6, release 2018. And if you're using other versions of it, particularly the older versions, the dialog boxes may be different, but the icons may be different, but you should be able, with minimum effort, try to fix it. Okay, good. So now we're going to create my geometry. Okay, so let's go here. Already created a part file. Okay, so let's go to generative shape design. Okay, so on a convenient plane, on that vertical plane, I will sketch the arc and then extrude it. So my arc is going to be a 3-point arc, for example. So I'm going to do, make sure my grid is showing up here. Where's the grid? Okay. So 3-point arc is going to be 1, 2, 3. We'll clean it up in a minute. Okay. A couple of things. First of all, I want this point, the center of the circle, to be on that axis. So that control this center, we're going to make it coincident. Let's try it again. Just a second. Arc control this arc, or not arc, sorry. The axis control the center of the circle. You're going to make it coincident. Okay, it looks like it was already coincident. And then we're going to dimension these things. So the radius of that circle, let's see now, the radius of the circle was, or arc was 15 inches. Okay, so 15 inches. So change that to 15 and fit it. Okay, and the distance from Uh, the left point of the arc to the right point of the arc is 14 inches. So let's go back there. So the dimension between this point and that point, this is 14 inches. So there's my arc, okay? And we're going to exit, and we're going to extrude it. Extrude, oh, that's projection. Extrude is right here. The length of this thing is 14 inches. You can see that it's 14 inches long. So let's do that. We can do 14 inches. There we are. Okay. Now we need to make the hole there. So what I'm going to do, the easiest way to make the hole is uh, create a plane based on these 3 points, and on that plane draw the circle, and then clean it up basically. Okay, so here's what we're going to do. We create a plane. Where are the reference elements? Let me get these things out. Okay, I can't find my reference element toolbar, so why don't we reset this thing? So tools, customize. Oh, it's up there. I'm sorry. I missed it. Cancel, cancel. Here's the plane, right there, plane. So based on 3 points, 3 points. Let's see. 3 points right there. So this is 1 point. Here's another one. Here's another one. We say, okay, so we created a plane that passes through these 3 points. So on that plane, we're going to sketch, okay, a circle right now anywhere, and then we're going to center it properly. So here's a circle. First of all, the dimension of that circle is diameter of 2 inches. Okay, and then we have to make sure that it's centered exactly. It's the center of it is exactly at the center of this panel. So let's see now. Here's how we're going to do that. We're going to say, for example, uh, left edge control. Let me actually do the following. Let me go ahead and yeah, left edge control right edge control the center of this. You make it symmetric, equidistant. Okay, good. Top line, control bottom line, control the center of this, again equidistant. So right now it's at the center, and exit. Please, you can do this thing any way you want. Basically, you have to create that panel with a hole. This is not the only way to do it. This is not the best way of doing it, but I'll let you decide how you're going to do that problem. Okay, now, one way of doing this thing is to extrude that cylinder, okay? Extrude that circle, see that? Extrude it. And then we're going to split this surface with the other one. So let's see, we have split. Read it carefully. Element to cut is that panel. The cutting element is this thing that we created. And let's see how it looks. It did, and I can hide that because I don't need it. There we are. Okay, or any other way that you want to do this problem. Okay, so let's save this thing. So file, save management, save as, desktop. I did a folder called buckling cylindrical panel with a hole. Let's see this one, January 14. So we're going to put it in there. And then we're going to, by the way, let me make a coordinate system here too, because we need a rosette and we're going to do that. So I just, it automatically puts it there, which is fine, no problem. You say okay. and I'm going to say not the current, and then okay. So we did create a coordinate system here that's going to be used as the rosette, and X is the only problem is the way it has done it is X is in this direction. My drawing shows X in the other direction. So we can clean this up. Let's do that. I want to make sure that it matches exactly what I have in the transparency. So we're going to rotate this thing by 90 degrees about the Z direction. So put the cursor on Z, right click, rotate 90 degrees. There. So if you look at it carefully, uh, yeah, X is in this direction, but Z is still up. So I rotate this thing about X by 90 degrees, another rotation. So double click, oops, fit. Okay, let's try it again. So here's my coordinate system. I want to rotate it about X by 90 degrees, about X by 90 degrees. Okay, so now when you look at the coordinate system, X is this way, Z is along the axis, of the cylindrical panel, and Y is obviously vertical. So this matches this coordinate system. All right, and we're going to save. This took longer than I thought. Okay, good. Now we're going to create our material, because the material we have to input. So we're going to go to Start, Infrastructure, Material Library. I'm going to rename this thing. Let me double click on it. Okay, so feature properties, and I'm going to call this thing buckling of panel, buckling cylindrical panel. Okay, very good. Apply, and so composite. The thickness of these panels was 0056. So we go 0.0056, 0.0056. Okay, apply. Unidirectional, apply. And for properties analysis, we're going to put our numbers. So this is 2D orthotropic. Now let's see what do we have here. 196 and 5 zeros. So this is 196, 96, 5 zeros, 1, 2, 3, 4, 5. The other one is transverse direction is 189 zeros, 189 zeros. So 189, 1, 2, 3, 4. Okay. Shear modulus, G12 is 93 zeros, 93, 1, 2, 3, 4. And the other one is also, so 1, 3, which is XZ, same thing, XZ right there, 9, 3, 1, 2, 3, 4. And shear modulus in the YZ plane is 63,000. 63, 1, 2, 3, 4. And Poisson ratio is right there, 0.38. Is that right? 0.38. Yes. We say apply, we say OK, and we're going to save this. Save that in this folder. There's my folder called buckling. I'll give it a name. Buckling cylindrical panel. Very good. We save it. Yeah. We get rid of this. Now, as far as geometry is concerned, material is concerned, we are done here. So now we're going to go to composite design. Okay, good. First of all, the parameters, composite parameters. And let me remind you, when it comes to composite parameters, this is what you're doing. In composite parameters, you're specifying on material, direction, laminates, and rosette. Okay, so let's do that. So add a material. We just created one on my desktop, and there is the uh, oops, wait a minute. I thought I put it there, didn't I? Let me see. It looks like I must have put it somewhere else. So let me see by accident. Uh, where could I have? Oh, by accident I put it somewhere else. But that's okay. It was this. I think it was that one. Right, right. I put it in the wrong folder. That's okay. Say okay. So it's right there. Yep. All right. The directions that we need are 0, 90, 45, minus 45, so we don't have to do any specific thing and we don't have to add anything here. As far as the laminate is concerned, we're going to add a laminate. And for thickness loss, so material, first of all, is cylindrical panel. Okay, and I need two. Let's look at the stacking that I have here. The stacking that I had is 245, 290s, 2 minus 45, and 2 zeros. So, okay, so we go here, two of those, and 290s. Okay, very good. So we say, all right. So we did create our laminate and rosette. For rosette, we're going to add a rosette, and we're going to select the one that we actually picked, which is right there, access system 1. Let me hide this thing. And we say, okay. So we close that. So we did this part, which was right there. Okay. Now we're going to go to uh, uh, zones. Okay. Now before I do that, one thing I forgot to do is to extract the boundary of this, because the boundary of this shape is going to be used as the contour for my zone. So what I'm going to do, I'm going to go back to generative shape design and get the boundary icon out right there. See that boundary? As a matter of fact, you know what I'm going to do? I'm going to join this thing too and then extract. So join this. Ordinarily, I like to join, and if you double click on it, it shows a draping. Well, the direction, that's not the draping direction. This is the direction of the surface. I'm going to flip it. Okay. Finally, I get the boundary. I could have got the boundary before, but you know, I just did the join and then extracting it. Okay, right there. There. So this is going to be used as the boundary of the zone. Okay, good. That's all right. Okay, so let me see. Did I extract the boundary here? I'm not sure. It looks like it's there. Okay, fine. That's fine. So I have my surface, which is that join, and I have my boundary. Okay. In fact, let's exit. Go back to composite design. Okay. So the first thing that we're going to go do is to create a zone group. So if you look at my transparencies here, first thing is zone group. Now, even if you try to do a zone, it will first create a zone group for you. Why don't I do that myself instead of being 4. So here's the zone group. The name is 1. Surface is there. The draping direction, I flip it in the other direction. Rosette is picked up automatic. So we created a zone group here, right there. Now we're going to create our zone right there. See, this is the next step. So if you look at the sequence, zone group, and then zone. Okay, you specify the contour and the laminate. So you go here, you click on the zone right there. Automatically it puts it in group 1 because there's only one group here anyways. And as far as the boundary is concerned, curve of the contour, I'm going to select this boundary. See that? It picked up the boundary of the zone. And as far as the laminate goes, right now there is none. So you use the pull down menu. There's laminate 1 that I created. Remember? 2, 2, 2, 2. And we say, okay. So a zone has been created and the information is given here. Notice that the total thickness of this laminate is, remember I had the thickness was 0.0056 for each ply and there is 8 of them. So that's going to be this much. Okay, good. Now what's the next thing that we have to do? So let's go back here. So we did the first step, second step. Then we go to the plies and we create plies from zones. Okay. So let's go ahead. There is your plies, and this first icon is plies from zone. You click on it. It says where's the zone? With zone group 1, and yeah. So just be careful here. If you go back to these slides, I had some dialog boxes here, and the one that we have right in front of us, this one, is the one over here. I want to check create full plies with ETBS, and then you give it the path. Okay, so here's what happened. So I want this one, create full plies with ETBS, and then generate. Oh, let me see now. What was the other one that we had to do? Just one second. We go back here, and yeah, that's fine. Okay. So generate data file. Yeah. So this is fine. All right, so here's what happened. Notice what I did was change this radio button, and I did not need this. That's okay. I just said okay. I did not need the path. Okay, just ignore this thingy. Okay, so the 8 plies have been created. Okay, so the next thing that we need to do is to go and say, okay, take this and export it as an Excel file. And why I want to do that is if you go here and say, okay, show me the plies that you created right there, ply exploder, apply. Let me change the scale here to 50 so that you can see it better. Notice that the order is not the order that I want. Okay, let me try this. Okay, the order of these plies is not what I want. Okay, so of course I can go through these one by one and change the angle. I can go here and say, okay, on that ply, let me cancel that. On that ply, the first one is not, it says 0 right now, but I know that my first one should be 45. Okay. I can do this 8 times, but the alternative way is to export a file, and you see, oh, that's what this thing is doing. Create a file, okay, and then go and manually change it there. So here's what we're going to do. We're going to say this, which is ply table. Now, select a group and tell me where this Excel file is supposed to go. So I'm going to specify the path. Specify the path. You see this? You have to specify the path to know where it went, and so that you can go and change it. Okay, so I'm going to put it in that folder. Oh, is this the right one? Yeah, good. Give it a name. So we go my exported file. Save. And okay, of course, it's going to open it for me. There we are. Okay. So notice that the angles are not correct, or not in the order that I want. I want plus, let me see now. I want plus 45, minus 45, etc. Okay, so this is going to be 45, minus 45, and then there's 90. Was it 90? Can't remember. Uh, 90, yeah, 90, right here. 90, 0, 0, 90, minus 45, and 45. Okay, so we're going to save this thing. File, save management. I'll call it my exported file modified. Modified. Okay, and save in that same folder and close that. So now that I modified my file, I'm going to go and import it. So if you look at the sequence, I did this. Now I have to go and import it, the next icon. So let's see. There's the import. This one. This one. I use this to export it. Now I use this to import it. Go and get that file. It was modified. Say OK and say OK. Now, if you look at the ply exploder, it should be in the order that we want it. Okay, you can see that plus 45, minus 45, 90, 0, 0, 90, minus 45, and 45. Very good. Save everything. Now, if you look at this, my stack of this is mirrored, so it's symmetric, double of these. Okay, that's very easy. And the icon to be used to do that is right there, symmetric price stacking. Okay, so we did all of this and symmetric price stacking. This is number 7. So let's go ahead and find this. It's right there, symmetric price stacking. Now, when you do that, it gives you two options, pivot and non-pivot. Okay, non-pivot means that in the middle, that in the middle, uh, this is going to be repeated. So what I mean by that is that it's going to be, if you look at this, 45, and then the next one is going to be 45. Okay, 45, and this thing repeated. Okay, but if you say non-pivot, then the next one is going to be minus 45, etc. So this is a terminology that's used in composites. What I want to do is say, let me see. I want to see non-pivot. Okay, pivot means not doubled. I want it to be doubled. Doubled means that when it ends at 45, the next ply, when I mirror it, is going to be 45, etc. But if you say uh, uh, pivot, then 45, the next one is not going to be 45, it's going to be minus 45. So please check some references on, I don't know, YouTube or on or Google on this business of pivot and non-pivot. I want non-pivot. Okay, so let's go ahead and do that. Non-pivot, and we say OK. Don't worry about that. Notice that there's going to be 16 of them, and in fact, if I use the ply exploder, where's the ply exploder? Right here. Okay, you can see what happened. This is the middle, which was repeated, and then the whole thing is stacked on top of each other. So instead of me creating these 16 times, make sure the angles are right, etc. I went through this path in order to get to my plies. The next video segment, I'm going to stop it here. It has been almost half an hour. And the next one is going to be starting at this point. We're going to do our buckling analysis.